Now we have a physical presence of Jane Calvert, who is here with us in person. And Jane is a sociologist of science, a professor of science and technology studies at the University of Edinburgh. She is fascinated by attempts to engineer recalcitrant biological systems in the emerging field of synthetic biology and recently completed a project called Engineering Life on this topic, funded by the European Research Council. She's currently investigating the place of the organism in synthetic biology, inspired by a study of synthetic yeast. She values interdisciplinary collaboration and was one of the instigators of the Synthetic Aesthetics project, which is also a wonderful book, which brought together biologists, engineers, artists, designers, and social scientists to explore what it means to design living things. And Jane will talk about Towards a Collaborative Sensorium. Thank you, Jane Calvert.
Hello, maybe, is that better? I think these are okay. This is better. Okay, this is better. Since I'm here in person and we're thinking about the body, I wondered if people wanted to just stand up and sit down again, because just standing up now was really great. I feel like we've been sitting down for quite, sorry to disrupt the, okay, everyone's enjoying it too much, so sit down now. But anyway, thank you very much to the organisers for this invitation. It's been something I've been looking forward to for months. It's been a real privilege to think along the lines of Anicka Yi's work and also to be challenged to think differently. Obviously, we are a very kind of a diverse group of speakers today, so I just want to say something about where I'm coming from. Geographically, I'm coming from Edinburgh in the cold north, so it's great to be here. But even from there, I have been inoculated by the Metaspore. And disciplinarily, I come from a field called Science and Technology Studies, which isn't a very well-known field, but I think it's brilliant, I love it. And this is the study of science and technology, but from the perspectives of the social sciences and the humanities. So I apply the lenses of anthropology, sociology, philosophy, history, politics, etc., to science and technology themselves. So the topic that I've been studying as a sociologist of science for the last 10 years or so is synthetic biology. And this is an attempt, to put it quite briefly, to make biological things more like machines. So it has lots of similarity to some of the work we've seen today. And this attempt to kind of engineer biology is something that these living systems often resist. And this is something that I find really interesting. And this also has lots of resonances with Anicka Yi's work on the organism and the machine, challenging these boundaries between the biological and the engineered. And so I'm going to start my talk today talking about this, and then I'm going to ask how challenging these boundaries could actually enable us to rethink the future of biology. But I'm going to argue that rethinking this future requires cross-disciplinary collaboration, requires particularly the input of artists. And finally, I'll turn towards the topic of the symposium, and I'll suggest that it is through collaboration with other organisms, with other people, that we can extend our sensory capacities and engage with other ways of being. So starting with the organism and the machine, we've heard a lot about this today, but I think Anicka Yi's work on the biologization of the machine is very inspiring, and this is both about making machines more biological and making biology more machine-like. And this is where I think synthetic biology can help us think about this. It's an explicit attempt, as I said before, to make biology more like machines. And this is an image that was produced by one of my synthetic biology colleagues, which shows this very explicit parallel between biology and machines. And I'm just going to give you an example of a project that I've been studying in synthetic biology. And this is an attempt to build an entirely synthetic version of the yeast genome, to completely reimagine it and redesign it. And this is the genome of the yeast species Saccharomyces cerevisiae, which people might be familiar with because it's very familiar in making bread and beer. It's the yeast that we use every day. So the synthetic biologists in making this synthetic yeast are calling it Saccharomyces cerevisiae 2.0 because they are very enamored of software, and so we can just treat it like it's a new upgrade of the original version, and it shows their connections to digital technology. And the types of things that they're doing here, they are removing what they consider to be unnecessary bits of the genome. They are inserting a new chromosome to make the genome more stable overall. And they're even engineering in the capacity for the yeast to evolve on demand, on our demand. To such an extent that the synthetic yeast could be argued to be an entirely new species. What's interesting here is that the yeast is entirely designed and built in silico, in a computer. So it is an organism whose parent is a computer, which is a line that I borrowed from Craig Venter. This means that it's detached from its species provenance and its evolutionary history. And it means that with the genealogical relationships we normally associate have been cut. But when the yeast is built in the lab as a real yeast, what was really striking was that the scientists' attitudes towards the yeast were very different. They suddenly became really enthusiastic about working with the yeast. They said that they really loved the way it smells because it often smelled like baking bread. So what they seemed to have was an affection for and appreciation of the idiosyncrasies of the yeast. So what we see here is in this transformation from the digital to the biological, that the sensory properties of the organism really come to the fore, which I think is interesting in this context where we're thinking about moving between digital and biological realms. One thing I find really fascinating about this project is that they, in building this synthetic yeast, even with all the massive changes they're introducing, they say the one thing they want to preserve about the yeast is what they call its yeastiness, which I really love this word. And so I think what this shows is that even in these attempts to massively change and engineer biology, the characteristics of the organism persist. So here, I think what we see is biology continually overflowing and exceeding the constraints of engineering. And the engineers have to be open to the possibility and potential of the living world when they work with it. But I don't want to underplay engineering here, because as we've seen in previous talks, engineering can create novelty. It can create potential biology that goes beyond actual evolutionary designs. It can bring new types of thing into the world. And this is something that we also find in art and in science fiction, of course. Just to give an example of it, this is Codex Seraphinianus, which is an illustrated encyclopedia with non-existent creatures written in a completely made-up language by the artist who's based in Milan, I think, Luigi Serafini. So my point here is, although biology has this emergent and unpredictable potential, that engineering can bring alternative biological futures into being. And this is a picture of an imagined alternative biological future put forward by the synthetic biology company Ginkgo Bioworks, which is one of the most prominent synthetic biology companies at the moment. And here we see humans happily coexisting with dinosaurs, and we see lots of mushrooms and fungi and some dragonflies. But obviously, this is a very utopic future. And I don't think we should forget that synthetic biology is very strongly connected to power and to capital. So industrialization, commercialization, and profit are the driving forces in the field. And new living things are likely to become the intellectual property of private companies, as they have done with genetically modified organisms in the past. So I think that one of the questions this symposium raises is really important. How do we encourage the proliferation of other futures, both biological and political, that go beyond these kind of driving dominant forces? This is a hard task, but this is one where I think that art is really important, because it can help us imagine possible futures and new ways of being. It can cultivate alternative dreams and cultures. And this brings me to the importance of cross-disciplinary collaboration. In reading about Anicka Yi's work, I was struck how important it was, and actually is something that has recurred throughout the talks today. Yi draws on work from the social sciences, the natural sciences, the humanities, and way beyond that. And also stresses the urgency of cross-disciplinary knowledge formation, which I hope is something that we're engaged in today. And cross-disciplinary collaboration is something I'm strongly committed to. I was involved in a project called Synthetic Aesthetics, and this brought together social scientists, synthetic biologists, and artists and designers. But what really struck me is that what emerged at the intersection of our different disciplines was more than and different from anything I could have ever imagined when I started that project. So this has made me very committed to trying to work at this intersection. So now I'll come on to the topic of the sensorium, and because of the importance of collaboration, I do want to argue that we should think in terms of a collaborative sensorium. But before I explain what I mean by that, I want to also talk about some of the struggles I've had thinking about the idea of extending the human sensorium. Because I think this is often quite an individualistic thing, or it's often portrayed as quite an individualistic thing, where like a rich white guy will have some kind of technological enhancement that's really expensive. And this seems to be sometimes a little bit frivolous or even recreational in a context where many people don't even have the correct prescription glasses to see properly. So it could be argued that it's perhaps more pressing to try to create new realities through social and political change, through trying to foster equality, rather than through extending our perceptual abilities. But I think if we think in terms of the collaborative sensorium, then this changes. It's no longer an individualistic thing, it's something that we can do together. And I think we can extend our collaborative sensorium in many different ways, just very simply through cross-disciplinary work. As I mentioned previously, I think this is really important, but when we work with people from other fields, we get to think and see in new ways. Just to give a couple of examples, I was working with a plant synthetic biologist, and he pointed out to me the liverworts, the marcantia, in the paving stones and the pavement, which I'd never noticed before, but now I see them all the time. A film studies scholar pointed out to me a very long tracking shot when I was watching a film, which I had not been aware of, and then I saw films differently from then onwards. Even a sommelier, when they talk to you about the finish of a wine, you learn, you grow, your sensory capacities increase, and then you drink you treat wine differently. Maybe more kind of cognitively, I think anthropologists in their empathetic writing about other cultures allow us to extend the bounds of what we think of as human experience. And there are other much more kind of pragmatic ways in which we can extend our sensory capacities through, for example, microscopes or telescopes that enable us to see things we wouldn't before. But we can only engage with these devices if we are in collaboration with the experts who have access to them. More broadly, we can think of collaboration with non-humans, and even broader than this, we can think of life as itself as a collaboration. The philosophers of biology, John Dupre and Maureen O'Malley, say that collaboration, not competition, should be seen as a central characteristic of living matter. They argue that life should be seen as a continuum of variably structured collaborative systems. And getting more specific, if we want to think about collaborating with non-humans, we can think about collaborating with things like dogs and horses, who we have collaborated with for much of human history. But I just want to give an example of the collaboration between a falconer and a human in hunting. And this is based on a lovely ethnographic study by Sarah Schroer. And she says, with increasing skills, over time, falconers' bodily and perceptual abilities were experienced as changing and as significantly shaped by their engagement with their winged companions. So this is a way in which we can extend our sensory abilities, but not through technological enhancement, but through just a kind of deep empathy with another form of life. And falcons and dogs and horses are quite easily accessible beings, but I think we can do this we can learn with less obvious creatures too. And I'm thinking here of the work of Barbara McClintock, who was a Nobel Prize-winning geneticist who worked on maize. And she was known for her reverential, attentive observation of the organism, which enabled her to generate new and scientific insights. So Evelyn Fox-Keller, the historian of science, has done a study of her work and says that over the years, a special kind of sympathetic understanding grew in McClintock, heightening her powers of discernment until finally the objects of her study have become subjects in their own right. And this obviously relates quite strongly to von Uexel's idea of Umwelt, which is one of the ideas underlying this symposium. So here we see that McClintock's attentive observation enabled her to inhabit a world that was not her own. And this may seem very far from the synthetic biologist's manipulation of the yeast that I talked about earlier. But actually, in my study of this project, I did find that they had a kind of feeling for their microorganism, that even while they were manipulating it, they were working with it to achieve shared goals. But I don't want to be overly simplistic about this. Their relationship to the yeast was ambivalent and perhaps even contradictory. They regarded them simultaneously as tools and partners, machines and collaborators, all at the same time. But what I think this shows is that intervening and manipulating can be combined with appreciation, and that an engineer doesn't necessarily have to have a straightforwardly exploitative relationship to the natural world. I haven't studied our relationship to non-living things, but I think that perhaps what we've heard today can make us think that we could extend our collaborations to encompass them too. So the suggestion I'm making is that we could start thinking in terms of a collaborative sensorium. And although collaborations will deteriorate without care and maintenance, I think by collaborating with other things in all their diversity, we can extend our sensory capacities and perhaps bring new possibilities to light. There's my references. Thank you. Shall I stop? Yes.